Next question is, which of the following is not the product of a compound given here is a tertiary butyl alcoholic compound. There are 4 alkenes given here. So, you have to choose dehydration of this gives almost 3 different compound probably according to the question. One of this is not a product. That is the question. Now, let us see the concept of this. So, this is a compound. This is a compound. So, dehydration take place in presence of sulfuric acid concentrate or in acidic condition H plus. That H plus is here. So, it becomes OH2 plus. So, this undergo dehydration. So, minus H2O. You get compound like this. Where the tertiary carbon acquires positive charge. That means you get a tertiary carbocation. So, in tertiary carbocation, this is tertiary carbocation, this is tertiary carbon, tertiary carbocation. This is alpha carbon, this is beta, this is beta, this is also beta. So, this tertiary carbon atom is attached by 3 beta carbon atom. So, this tertiary carbon attached by 3 beta carbon atom on which there are hydrogen. Supposing in case if this beta hydrogen eliminated, double bond between these 2 carbon atom. So, you get compound like this. Removal of this hydrogen, then double bond between these 2. You get compound like this, double bond. Supposing if this hydrogen is eliminated or removed, then you get alkene like this, double bond between these 2. Supposing if this hydrogen is removed, double bond between these 2. Double bond between these 2. Dear students, now these 3 compounds are possible. Now look at this and compare this. So, this compound is here, this alkene is here, this alkene is here. The one alkene which is not possible is option A. So, therefore, option A is not formed during dehydration of this alcohol. The next question is, in the reaction with HCl, an alkene reacts in accordance with Markovnikov rule of addition to give a product called 1-chloro, 1-methyl cyclohexane. The possible alkene is, there are 4 alkenes given here, all of them are derivatives of cyclohexane. In the reaction with HCl, an alkene reacts in accordance with Markovnikov rule to give a product 1-chloro, 1-methyl cyclohexane. The possible alkene is, remember, so this is an important rule in hydrocarbons. When an unsymmetrical reagent like HCl adds on to unsymmetrical alkene, the positive part gets attached to a carbon atom containing most number of hydrogen atom. Understood? The negative part of the reagent should get attached to a carbon atom containing less number of hydrogen atom. Let us deal with these options. Option A, if I try out, this is option A, double bond CH2. Suppose if I add hydrochloric acid to this, addition reaction take place according to Markovnikov rule of addition. So this is CH2, this is CH. So this has less number of hydrogen, this has more number of hydrogen. So therefore, the H plus part should get attached to a carbon atom containing most number of hydrogen atom. Whereas the negative part of the reagent should go to carbon atom containing less number of hydrogen atom. Then what is the resulting product? This is your resulting product. This became CH3 and you have Cl here. This is 1-chloro, 1-methyl cyclohexane. So first one gives. Second, let me try out. Second one is this compound, methyl cyclohexene, something like this. Addition of hydrochloric acid to this, will it give the same compound? Let us see. This is CH, this is CH3. Now, this Cl should get attached to a carbon atom containing less number of hydrogen atom, and this H plus goes to this carbon atom. So, giving the same compound. 1-chloro, 1-methyl cyclohexane. So, last one if I try out, I don't get, because addition take place between these two carbon atom. So, therefore, option A and option B, both these alkene give a same compound, 1-chloro, 1-methyl cyclohexane. So, therefore, option C is correct one. The next question is CH3, CH2, CH double bond CH2 plus HBr in the presence of peroxide as a catalyst, giving you compound X and Y. 1-butene is subjected for addition reaction with HBr in presence of peroxide as a catalyst, giving compound X and Y. X and Y respectively are. Dear students, this is against the Markovnikov rule, anti-Markovnikov rule of addition. This is an unsymmetric alkene, this is unsymmetrical reagent. Unsymmetrical reagent adds on to unsymmetrical alkene in presence of peroxide as a catalyst, giving anti-Markovnikov product as a major product. Now, let us see. CH3, CH2, CH double bond CH2 plus HBr. In presence of peroxide, we get two different products. One as a major, which is in accordance with anti-Markovnikov rule of addition. Now, this is having more number of hydrogen atom. Here, the halogen atom gets attached. And this having less number of hydrogen atom, here the hydrogen atom gets attached. So, the product you are going to get is CH3, CH2, this is CH2, CH2, Br. So, 1-bromo-butane is a product. Supposing if this happens other way, if this halogen goes to this carbon atom, like in case of Markovnikov, and if this hydrogen goes to this carbon atom, then the product is going to be CH3, CH2, CH, Br, this is CH3. So, you should get 2-bromo-butane. So, this is 1-bromobutane, this is 2-bromobutane. So, this is according to anti-Markovnikov rule of addition. This is according to Markovnikov rule of addition. So, therefore, this is a major product, this is the minor product, and this is your X and this is your Y. So, the X and Y are, now let us compare the options given here with the product we got. First one, it cannot, because your double bond still persists here. Second one also can be ruled out because you have alkene still left over. And the third one, let us check. CH3, CH2, CH2, CH2Br, it's here. C2H5, C2H5, CHBr, CH3. So, 1 bromobutane and 2 bromobutane is option C. Option D also same, but it is the reverse. This is the minor product according to Markovnikov rule. This is a major product according to anti-Markovnikov rule. So, therefore, option C should be the correct option. That is, 1 bromobutane is a major product, 2 bromobutane is a minor product. This is your X and this is your Y. This is minor, this is major. Dear students, remember, anti-Markovnikov rule addition take place only with HBr, only with HBr. So, this addition reaction do not take place with HCl, HI. Why it do not take place? Why HI and HCl do not undergo addition reaction according to anti-Markovnikov rule? That is because during the propagation step, the process is going to be endothermic. Since during propagation step, the process is endothermic, it is not feasible. That is, addition of HCl and addition of HI are non-feasible reaction in the propagation step of addition reaction. So, therefore, addition of HBr is only feasible because during propagation step, the addition of HBr is exothermic phenomena. So, remember, addition of HBr to unsymmetrical alkene in presence of peroxide as a catalyst take place against the Markovnikov rule called anti-Markovnikov rule or Karash effect, but not HI and HCl undergo addition reaction like this. So, for this question, option C is correct one. The next question, which of the following reagents will be able to distinguish between 1-butane and 2-butane? Dear students, 4 options are given here: soda amide, HCl, oxygen and bromine. Let us see the structures of these two. First one is 1-butane, CH3, CH2, C triple bond, CH. And next one is 2-butane, CH3, C triple bond, C, CH3. So, this is 1-butane and this is 2-butane. 1-butane, 2-butane. The difference is that this is a terminal alkyne, this is non-terminal alkyne. The terminal alkynes are acidic in nature. The acidic nature of these terminal alkyne is because of hydrogen attached to carbon atom, this hydrogen. So, this hydrogen atom is acidic in nature. That is because the carbon atom here, it is sp hybridized. Because of sp hybridized, the carbon acquire negative charge, and therefore, this hydrogen acquire a positive charge. So, sp hybrid orbital has got almost 50% of s character. Because of more s character, the carbon atom is going to be more and more electronegative. Because of that reason, this hydrogen atom becomes acidic in nature. Acidic in nature. So, when an alkyne is acidic in nature, is treated with soda amide NaNH2 or metal like sodium or metal like silver, this hydrogen atom get replaced. So this Na replaces this hydrogen, you get compound like this, CH3, CH2, C triple bond C Na plus C minus. Now this is an acetylide, it is a salt which is a precipitate which can be recognized, which can be detected. Whereas this butane do not undergo this reaction because of absence of acidic hydrogen. Therefore, the first option should be the correct option. The next question, one butane reacts with hot alkaline KMnO4 to produce. So here are the options, one butanoic acid, one propanoic acid plus carbon dioxide, propanoic acid plus formic acid or methanoic acid. Let us see the oxidation process. One butane is this CH3, CH2, C triple bond CH. This is a terminal alkyne. So this upon oxidation oxidation take place here. You should get CH3, CH2, COOH plus HCOOH. You should get HCOOH and CH3, CH2, COOH, propanoic acid and formic acid. But this formic acid further undergo oxidation forming carbon dioxide and water. So therefore, the option must be propanoic acid and carbon dioxide. So if you look at the options given here, option C should be correct one, CH3, CH2, COOH plus carbon dioxide. The next question, among the following, the aromatic compound is, there are 4 compounds given here. First compound, cyclopropenyl carbocation, cyclopentadienyl carbocation, cyclobutadiene, cyclopropenyl anion. So among this, which one is aromatic? Kindly recall the synopsis we have discussed earlier in this session. So any compound which fulfill the following characteristic would be aromatic. Number 1, the molecule must be cyclic and planar. The molecule should have conjugation, alternate double bond, single bond. The molecule should have a single pi electron cloud encompassing or enclosing all the atoms present in a cyclic ring system. And moreover, the molecule must obey Haeckel's rule. What is Haeckel's rule? 4n plus 2 pi electron rule. The value of n can take 0, 1, 2, 3, 4, etc. So remember, any cyclic compound which are having number of pi electron equal to 2, then 6, then 10, then 14, then 18, etc. So this conjugated systems which containing 2, 6, 10, 14, 18 electron, etc. will be aromatic according to Haeckel's rule. Now look at this, there are 2 electrons here, so therefore it is aromatic. There are 4 electrons here, anti-aromatic. 4 electron, anti-aromatic. 4 electrons, anti-aromatic. Therefore, option A should be correct one. Cyclopropenyl carbocation is the right option. The next question, which of the following compounds will not undergo Friedel-Crafts reaction? So, 4 options are here. Option A, nitrobenzene. Option B, toluene. Option C, cumene. Option D, xylene. Now, let us see the concept. Friedel-Crafts reaction nothing but substitution of an alkyl group into the benzene ring or aromatic ring in presence of anhydrous aluminum chloride as a catalyst and an alkyl halide. Now, this is your nitrobenzene, and this is your toluene or toluene, and this is cumene, nothing but isopropyl benzene, and this is your xylene. So, all the 4 compounds are written here. This is nitrobenzene, methylbenzene, xylene and cumene. Here the nitro group is strongly electron withdrawing. Therefore, it deactivates the benzene ring to such an extent, sometime nitrobenzene will become unable to undergo Friedel-Crafts alkylation reaction. So, therefore, option A should be correct one. Then what about this? In case of methylbenzene or toluene, methyl group is electron releasing group. It releases electron into benzene ring. In this case, this also releases electron into benzene ring. Here, this also releases electron into benzene ring. Since in these 3 cases, the benzene ring is attached by electron releasing group called alkyl groups, the benzene ring gets activated for further substitution reaction. In fact, these 3 molecules undergo more readily Friedel-Crafts alkylation reaction. So, the question is, which of the following will not undergo Friedel-Crafts reaction? The answer is option A, nitrobenzene do not undergo Friedel-Crafts reaction because of very strong electron withdrawing group deactivate the benzene ring to such an extent where the nitrobenzene become incapable of undergoing Friedel-Crafts alkylation reaction. So, therefore, option A is correct one. The next question, nitrobenzene can be prepared from benzene by using a mixture of concentrated nitric acid and concentrated sulfuric acid. In the nitrating mixture, nitric acid acts as. So, nitration of benzene is nothing but benzene when heated in the presence of concentrated HNO3 and concentrated H2SO4, you get nitrobenzene plus water. This is the overall reaction. Here the electrophile is NO2 plus. Nitronium ion is electrophile. It is generated by this HSO4 sulfuric acid. So, this gives you H plus HSO4 minus, and your nitric acid is here OHNO2. Now, so the H plus ion coming from the sulfuric acid accept the pair of electron from this O. So, you get NO2 plus. Now, this pair of electron goes with oxygen, giving you NO2 plus plus H2O. So this is how nitronium ion is generated. Now look at this, this is acting like an acid, H plus ion. This is a donor of electron pair, therefore this is acting as a base. So remember, nitric acid in the presence of sulfuric acid concentrated during nitration acting as a base. Nitric acid acting as a base during the nitration of benzene. So therefore, option A should be the correct one, base. The next question, chlorobenzene on treatment with sodium in dry ether gives diphenyl. Diphenyl. The name of the reaction is, so this is chlorobenzene. Chlorobenzene. When heated with sodium metal in presence of dry ether as inert solvent, you should get diphenyl. This is biphenyl or diphenyl. Remember, this is nothing but Fittig reaction. Alkyl halide only Hoods, aryl halide only Fittig. Mixture of alkyl and aryl Woods Fittig reaction. Woods reaction gives you alkanes. Woods Fittig reaction gives you alkyl benzene. Woods Fittig reaction gives you alkyl benzene, whereas Fittig reaction gives you biphenyl or diphenyl. So therefore, the option cannot be Woods Fittig, cannot be Sandmeyer's, cannot be Guttman, should be correct one, Fittig reaction. Conversion of chlorobenzene to diphenyl is a Fittig reaction. The next question, liquid hydrocarbons can be converted to a mixture of gaseous hydrocarbons by, dear students, conversion of higher hydrocarbons into smaller chain hydrocarbons is called as cracking. So cracking is done by heating higher hydrocarbons at high temperature under pressure of 6 to 7 atmosphere pressure. So under pressure on heating, longer chain hydrocarbons converted into smaller chain alkanes, alkenes, and sometime even alkynes also. So during cracking or pyrolysis, both are same. During cracking, carbon-carbon bonds are broken and even CH bonds are broken. So therefore, you get a mixture of alkane, alkene and alkyne containing smaller chains. So here, liquid hydrocarbons, when I say higher hydrocarbons, the smaller chain hydrocarbons are gaseous compounds at room temperature. Little higher carbons like decane, etc., containing 10 or more carbon atoms can be liquids, and little more higher carbons can be solids at room temperature. So when I say liquid hydrocarbon, nothing but higher hydrocarbons. So higher hydrocarbons converted into gaseous hydrocarbon means lower hydrocarbons, that is containing 2 carbon, 1 carbon, 3 carbon, 5 carbon, hexane, heptane, such compounds, methane, ethane, ethylene, acetylene, these compounds. These compounds are gaseous compounds at room temperature. So conversion of higher hydrocarbon into lower hydrocarbon in presence of temperature and pressure, sometime if you want catalyst also, the process is called as cracking or pyrolysis. So therefore, option C should be correct one, cracking, which is sometimes also called as pyrolysis.